This is, I will talk to you on very small experience as a control center manager of the ATV, which is the supply vehicle to the space station. But before starting, I wanted to say a big merci to all the guys who presented before me and made this possible. So I will present you the ISS operation concepts from the European point of view, then some words on the ATV Jules Verne mission. Jules Verne was the first ATV. Then word on the upstream, the change of the ATV operation, and the lesson learned. It's only seen from the operational point of view, because I was in charge only of the operations. Space activity, space job is great, and operations is much better. So that's my point of view, but something also I heard yesterday. So the European Space Agency, ESA, is in charge of, I think I'll take that otherwise, is in charge of the development and management of the European participation of the International Space Station. It's a single interface to the other ISS partners, but in fact it's a lot of countries behind that. And the two major contributions are Columbus Laboratory, which is a permanent module of the space station, and the ATV, which is a supply vehicle. In fact, it's a barter. It just provides services to the space station in terms of cargo delivery and propulsive support, just to participate to the cost of the exploitation. And the ISS operation concept is based on architecture where each partner is in charge of operating its own facilities, and the same was kept within Europe. Scientific User Operation Center distributed amongst most of the countries. The ATV Control Center is operated by and developed by CNES in Toulouse, and the Columbus Laboratory is operated by DLR near to Munich. And as you can see, this is a typical non-technical system engineering. And particularly in Europe, we are confronted to that every day. So I just wanted just to show you, yeah, I took that on your website, in fact, and here is Toulouse, ATV Control Center in Toulouse, and you see all the towns and part of the world involved in the ISS operation. So Jules Verne mission, launched by Ariane 5 from Kourou. It was a premiere because it's the heaviest vehicle ever launched by Ariane, and the mission itself was a reignition of the last stage, and after deorbitation of the last stage for safety reasons. Then we have a free-flying vehicle. Then we have a docking on the Russian side of the space station. In fact, we are using the Russian port, which is in the axis of the space station. Then we are becoming a permanent module of the space station, where crew can go in. We are also having a propulsive support for the space station. We say dock up to 6 months, and then we have a destructive re-entry, no return capability. And for the first flight, in fact, we had to make several approaches and demonstrate the safety vis-à-vis the space station. So we had to make, in fact, 3 rendezvous attempts. 2 was only for demonstration purposes, and we made we flew around the space station, and then at last we docked to the space station. So the operation team, in fact, so we had teams in Toulouse, people from CNES, people from ESA, and also people of flight segment. Around 130 engineers were working in the operation in Toulouse. But we were also interfacing, and I think it was a premiere because the 2 main control centers of the ISS were also active during our operation. Moscow, of course, because we docked on the Russian side, and Houston for the overall safety, and to give the go for the different phases. And for the undocking, we also interfaced directly with the ISS crew. The rest of the time we're interfacing via Capcom. We're also interfacing with Guyana Space Center in French Guyana, the Columbus Control Center, because it's also in charge of all the communication for the European ISS operation, and Artemis relay satellite. We are also using TDRS relay satellite, but via Houston. So challenges, premiere for Europe, It was very first time that we had active participation to the space station, and also it was the first automatic rendezvous with optical navigation ever performed. The mission changed. It was a 4-month mission to be launched in 2003 at the beginning. Eventually we launched on March 2008. We also should have docked directly to the space station, but we had to cope with the shuttle launch and a lot of progress operation also. So we had to go in a parking phase in front of the space station just to wait that we can dock. And it was Endeavour, which was STS 123. And during the mission itself, in fact, because we didn't use a lot of propellant, we can extend the duration of the mission and make reboost of the space station, especially at last for debris avoidance maneuvers. So just to show you the type of schedule we have, here on this axis you have the date of the prevision, of the prediction maybe, and the launch date. And you see that from 2004 onward, we stayed parallel to time which was progressing, which means that we were at less than 1 year of the launch date for more than 4 years. So we had to manage the teams and keep them motivated. This was one of the challenges. At the end, we fulfilled all our mission objectives, all the mission, and no operation or no mission events were delayed thanks to operator ever. And also, after that, it was the first ATV. We had 3 years with ATV2, which is today docked to the space station, and from now on, we'll have 1 ATV per year. So we had to analyze, to go through a complete knowledge management and lessons learned exercise for the operation, and to improve the operation and make them safer for the next ATV. But due to impacts on qualification, the vehicle itself will not evolve as we would have averaged. Lessons learned and why I think it worked. I tried to keep it short. So first of all, is from the very beginning we established strong link between ESA, CNES, and the ISS partners. ISS partners seen from us is you, the Russian mainly. And this was possible because France has very strong links with Russia. Jean-Louis Chrétien was, I think, the first Western spaceonaut to fly on the USSR on the USSR station in '82, and this allows us to have very strong links, and also, of course, with Houston. And this was a major factor of the success. Another thing was very important, it's system validation test. We had the first validation test in 2003, which means 4.5 years before the launch, but it was the first step when we had something concrete. People working on the control center since '97 could eventually dialogue with the vehicle itself. And this was really helped to keep the team motivated because we had something concrete to do. Also, we had a test. Anytime we had an evolution we could not avoid, we had to test it on an independent configuration, and so test again. Also, we had very good training of the teams with structured training. I think something learned from you and the way you perform your operation with independent training instructor, and very, very organized, and the qualification exercise validated both jointly by ESA and CNES. And also we had also important simulation exercise with the partners. We had for them, I think, more than 100 people on console for qualification tests. All together, this was really important, including during the operations themselves. We had joint simulation, including crew, to prepare the undocking of the ATV. And to minimize the risk, we had all the development team and the ops preparation team involved in the operation during the whole mission, because a lot of knowledge was not written down. So, and this lesson was written 1 year ago, so it's not If you hear the same message as yesterday's, because I think we are on the same wavelength. So key personnel involved from the early phase for 12 years. Same guys at the key position, knowing and having the expertise on all the aspects of the flight. Excellent team spirit built along the project. This allows us to overcome the difficulties, the complexity of the ATV, of the operations, the problem during the operation, very intense operational period, and after docking, nothing. I would say dormant mode, it's called, when the ATV is docked, but we're also to cope with that. And something which is important, in fact, 9 seconds after launch, the propulsion system switched off. It switched also to the redundant chain, and we had to stop the operation, so otherwise we went into survival. And all the teams, the experts from industry, from ESA team, NASA team present during the operation on site, and us, we had to find a solution to use all the best of our knowledge to find solution. And we did it. But thanks to that, from this time onward, we had no more teams. We had one single team with expertise. And this allows us really to fulfill the mission. So once again, what's important is really to have one team. So to conclude, I think that international cooperation is the real way forward. It's where we all have to go. And I like this picture. So it's taken from the shuttle. So shuttle is not on the picture, but nevertheless, you have the HTV cargo vehicle, which was moved from the docking port to this port by the Canadian arm. You have the Russian vehicles. So you have one Progress and two Soyuz. You have the European cargo vehicle. You have the European laboratory. You have the Japanese laboratory. You have US and Russian model. And I think here we have what the mock-up of our future. Thank you.